Good evening to all. Let's discuss about the surge control, which is uh, which is called surge control on DP flow versus DP pressure. In surge control, compressor has to be tested minimum 3 sets of data. Minimum 3 is required, or it can be more also, but minimum 3 will give good results. Suppose once machine is surge tested. Then data is shown as a DP flow. DP flow is a flow differential pressure flow of any flow measuring device. Either it can be orifice, venturi, or any other flow meter, Annu bar, or etc., or caliport, or any other devices used for flow measuring devices, which is measured as a DP flow. Similarly, DP pressure is a differential pressure, that is a final pressure minus suction pressure of compressor. If it is multi-stage, so final discharge pressure of last stage minus suction pressure of first stage is a DP rise or DP pressure. So first DP flow, as I said, a differential pressure across any flow measuring device. DP pressure is a flow final pressure minus suction pressure of compressor. Now, whatever data we are measuring in a DP flow, DP pressure, that has to be converted into the raw value. And raw value can be 0 to 10,000, 0 to 16384, or any number is possible. So we need to convert this engineering value, that is DP flow or maybe MMWC or any other unit, or DP flow in bar or kg. Both has to be converted into the raw. That raw can be 0 to 10,000 or 16,384 or any number. Now the surge test, this is just an example to make you understand the how surge line and control line and run, and how surge control is configured. So let's say there are 3 points. This is surge point, there is surge point 1, surge point 2, and surge point 3. And DP flow after conversion, that is now I'm showing the only the raw data. Let's say this is a raw data for DP flow, and this is raw data for pressure, DP pressure. So first point we are 4,000 to 6,000. For second point, the DP flow is 5,000. DP pressure is a 7,000. For third point, it is 6,000 for DP flow, and this is for 8,000. This is just a number for understanding purpose. Now I have to draw these raw data, that is DP flow as on x-axis and DP pressure on y-axis. So I have to draw these data. I have shown these point 1, point 2, and point 3. These are 3 points we have drawn based on the data, search data. This is second step. Now third step, we have to join these 3 points. Closely, we have to draw a line which is be passing closer to all these points, and this line is called the surge line. So after connecting up to this point or this point, this is called the surge line, because this line represents the surge points or surge data points. Now, if you see the surge line, it has two very important parameter. One is called surge bias, BS we call it. Surge bias is the offset of the line from the 0 point. So this is called surge bias, and it has a slope that is theta. So this line has a slope or surge line slope from the x-axis. So this is theta, it is shown. So this surge line has a slope and surge line has a bias. The two important terminology we have to use this. Now we need to give another, we have to draw one more line which is parallel to surge line, and the bias will be control bias, which is lower than this surge bias. These are parallel line. Since it is parallel line, so theta remains same, that is slope is same, but the control bias BC is now smaller than BS. So this is called surge margin we have given, considering the same slope. Now let's focus only on the surge control line, because this is a line under which surge control system works. So this is, now we can see this is surge control bias, that is BC, and theta is a slope for surge control line, which is equal to surge line also, slope are same. Let's say this is operating point in the system, machine is operating, compressor operating here. Now let's discuss about these points carefully. If you see, this has a, in terms of rho, it has a flow. We can call, let's say it is a dp flow. This value is a number which is written as dp flow corresponding this point, and it has also dp pressure because it has certain pressure. So this is point where compressor is working. Okay, let's see. Now we need to find out what is this point and this vertical line where this control line touches. But tan theta, which is called gain or slope, we can call, let's say, G. So tan theta is a slope is equal to this by this, which is gain or which is also called G. So now we can see, if you multiply G into dp flow, this will be this much, because slope, this divided by this is G. So G into dp flow, that this much will give this much height. And control bias is BC, it is already there. So we have now set point, which is control bias plus, that is, this is the same this. So control bias plus G into dp flow. So this is set point. So at any operating point, if you know the dp flow, just multiply with the G and add the control. Control bias is the number which is fixed now after setting the surge. G is also fixed, only variable is the dp flow here. So set point is now known. Process value is a dp flow, sorry, dp pressure. So this is a pressure. So when PV means this one is less than set point, that means this value, machine is a safe, and so control valve will close the, sorry, and the controller will allow to close the surge control valve. But when this is greater, the valve will get open. That means this is operating point. So this is a safe region. Surge control can also be expressed in another way. So how we can express, which is called surge error. Same thing. If you see, surge error is this much portion. So the vertical offset of the operating point from from the control line. So you can say surge bias, control bias, this is this much, plus G into dp flow is this much, minus this much you have to minus, this will give the surge error. So in this case, set point is a 0. So process value is a surge error. So this is surge error, and set point is 0. So when process value is greater than set point, so machine is safe. So this, if this is more, this is safe, and in this case, controller will allow to close the anti-surge valve. So I hope you have understood the control logics for dp flow by dp pressure. Thank you for watching.